2019 August, simple harmonic motion. The points O, A and B lie in that order, with O lowermost on a line of greatest slope of a smooth fixed plane inclined at an angle pi by 6 to the horizontal, such that OA is equal simple A and AB is equal to A. One end of a light elastic string of natural length A and modulus of elasticity mg is attached to the point O, and the other end to a particle P of mass m. The string is pulled along the line OAB until the particle P reaches the point B. Then the particle P is released from rest. Show that the equation of motion of P from B to A is given by x double dot plus G over A into x plus A by 2 is equal 0 for x greater than or equal 0 and less than or equal to A, where AP is equal x. Let y is equal x plus A by 2 and rewrite the above equation of motion in the form y double dot plus omega squared y is equal 0 for y greater than or equal A by 2 and less than or equal pi by 2, where omega is equal square root of A over G. Find the center of the above simple harmonic motion and using the formula y dot squared is equal omega squared into c squared minus y squared. Find the amplitude c and the velocity of p when it reaches A. Show that the velocity of p when it reaches O is square root of 7GA. Show also that the time taken by P to move from B to O is square root of A over G into cos inverse 1/5 plus 2k, where k is equal square root of 7 minus square root of 6. When the particle P reaches O, it strikes a smooth barrier fixed at O perpendicular to the plane. The coefficients of restitution between P and the barrier is E. Show that if E greater than 0 and less than or equal 1 over square root of 7, then the subsequent motions of P will not be simple harmonic. Answer for this question. This is one of the inclined plane, 30 degree to the horizontal. Some points are here. Here points O, here points A. OA is equal simple A, and here point B such that AB is equal to A. This is one of the fixed barrier at point O. One of the particle is tied up to a string of natural length A. To here the string gets taut. String is stretched up to point B. Stretch up to point B. Modulus of elasticity lambda is equal mg. Particle P is released from rest at point B. So now watch the motion. Natural length A, therefore until come to A, string is stretched, then here string will get slack. String becomes slack here. slide. Let the particle is at distance x from point A. Here x greater than or equal 0 or less than or equal to A. That means this distance is a x. Particle is at distance x from point O. The x. Let the acceleration of particle is x double dot. At this instant, acceleration is x double dot here. The distance of x increasing, x double dot. Let the tension on the string is T. String is stretched, therefore there should be a tension, that is T here. This is a T tension. By Hooke's law, we can find out the tension. When the string is stretched, the tension can be found out by using Hooke's law. So T is equal what? T is equal lambda modulus of elasticity into extension over natural length. Extension x, natural length of string is A. Therefore, T is equal lambda x over A. But we are given lambda is equal mg. Therefore, T is equal mg x over A. Weight of the particle is mg. Vertically downward. Equation of motion. First question, we want to find out the equation of this motion. We will use Newton's second law, downward along the inclined plane. Therefore, resultant force here T and also components of this weight mg cos 60. Therefore, resultant force mg cos 60 plus T is equal mass m into acceleration x double dot. But x double dot is the opposite direction for our using direction. Therefore, m into minus x double dot. When we simplify further, mg by 2 cos 60 is a half mg by 2 plus mg x over a. That means T here. T mg x over a is equal minus mx double dot. M is cancelled from both sides. G by 2 plus g x over a is equal minus x double dot. Therefore, x double dot plus gx over a plus g by 2 is equal 0. Therefore, x double dot plus g over a into x plus a by 2 is equal 0. Here, x lies between 0 and 2a. For this motion, have a look. X should be greater than x should be greater than 0 and less than 2a. Less than 2a. The next part, we derive the above equation in the form y double dot plus y omega squared y is equal 0 by substituting y is equal x plus a by 2. So using the substitution, rewriting the above equation, substitution y is equal x plus a by 2. Now we differentiate this equation with respect to time. Therefore, y dot is equal x dot plus, this is the constant, when differentiate, this is 0. Therefore, y dot is equal x dot. Differentiate again with respect to time. Therefore, y dot, when differentiate, it is y double dot is equal x double dot. When substituting the equation here, y dot, say x double dot is a y double dot and y is equal x plus a by 2. Therefore, y double dot plus g over a into, for this one, x plus a by 2 y. Y double dot plus g over a into y is equal 0. When we simplify further, y double dot plus omega squared into y is equal 0. Here, omega is equal square root of g over a. Here x greater than or equal 0 and less than or equal to a. Adding a by 2, 0 plus a by 2, here x plus a by 2, here 2a plus a by 2, inequality never change. Therefore, this one a by 2, x plus a by 2, we can substitute y, 2a plus a by 2, 5a by 2. Next part. Next part, find the center of the above simple harmonic motion and using the formula find the amplitude and the velocity at point A. Finding center of oscillation, amplitude and velocity at point A. We already know y double dot plus omega squared y is equal 0. Center of oscillation will be get when y is equal 0. When substitute y is equal 0, we can get the center of oscillation. But y, we already know x plus a by 2, this is equal 0 to get the center of oscillation. Therefore, x is equal minus a by 2. Therefore, at minus a by 2 distance, the center of oscillations will be kept. Center of oscillations, say M. Therefore, this M is a midpoint of OA because OA is equal A. From A, minus means this negative this direction. X is increasing in this way, therefore minus a by 2 means the center of oscillation will be in this direction. A by 2, OA is equal A, this one A by 2, therefore M center, this is the center of oscillation and also this is midpoint of OA. Now we use the formula y dot squared is equal omega squared into c squared minus y squared to find out the amplitude. We want to find out the amplitude using this formula. For this equation, all distance measured from the center of oscillation. When we use this formula, all distance must be measured from center of oscillation. At point B, here at point B, velocity of the particle is 0 because particle is released from here. Now from the center of oscillation at point B, the particle velocity of the particle is 0. That means y is equal a by 5a by 2. From here, this one a by 2, and from A to B, this is a 2a. A by 2 plus 2a is equal 5a by 2. at distance 5a by 2, y dot velocity is a 0 here. This one here. This is the meaning. Y is equal 5a by 2, y dot is equal 0. Now we substitute this one in this formula, we can find out the C, amplitude. When substituting at the above equation, so y dot squared, y dot is equal 0, therefore y dot squared also 0 is equal omega squared into bracket c squared minus for this y 5a by 2. 5a by 2 all things squared. Therefore 0 is equal c squared minus 5a by 2 all things squared. Therefore c is equal 5a by 2 amplitude. So amplitude is a 5a by 2. Amplitude 5a by 2 from the center of oscillation. The amplitude. This is a by 2, here 2a, here 5a by 2. Here velocity is a 0. Amplitude. Point A is at distance, point A is at distance a by 2 from the center M. Let the velocity at point A is u. We want to find out the velocity at point A. Our next question. Let the velocity is u at here. Substituting at this formula, we want to find out this y dot squared. Therefore, that is the u squared is equal g over a into this amplitude c 5a by 2 whole thing squared, and this distance y is equal a by 2. Because we want to find out the velocity at point A. This point A is distance a by 2 from the center. Now here I put a by 2. So when we simplify this one, g over a into 25a squared over 4 minus a squared over 4. Therefore this is 24a squared by 4. This one simplifies 6ag. Therefore velocity u is equal square root of 6ag. That means the velocity at this point A, 6 square root of 6ag. At this point E. Here 6ag. Before becomes slack, the string velocity is square root of 6ag. Next part, finding velocity at point O. We want to find out the velocity at this point O. After coming this position, point A, string will become slack. Therefore, the motion from A to O under gravity. There is no tension on the string. String is slack. Becomes slack. Therefore, from A to O, we use equation of motion under gravity. We want to find out the velocity at the point O. Therefore, what is the formula we can use? When particle reach at point A, the string becomes slack. Therefore, no simple harmonic motion but gravitational motion. Here gravitational motion. Let the velocity at point O is v. The separate diagram I put here. From here A to O, gravitational motion. But here the velocity square root of 6ag we already find out. We want to find out the velocity at O, so v. Now what is the equation of motion we can use? V squared is equal u squared plus 2as equation of motion. Our final velocity v, initial velocity is square root of 6 ag, move distance a, and along this distance we want to use the acceleration v squared is equal 6 ag, u squared 6 ag plus 2 gravitational acceleration vertically downward g. Therefore, along this plane, the AO direction, g cos 60 into s distance, more distance from here to here, a. Now 6 ag plus 2 ag cos 60 half. And 7 ag. Our velocity v is equal square root of 7 ag at point O. Finding time to move from B to O. The next part question show also that the time taken by P to move from B to O. From B to O. You want to find out the time from B to O. So B to O, from B to A, simple harmonic motion, from A to O, gravitational motion. Therefore, we want to calculate two times separately. B to O, B to A, simple harmonic motion, and A to O, gravitational motion. B to A, simple harmonic motion, then A to O, there is no tension in the string, therefore gravitational motion. Simple harmonic motion from here to gravitational motion. So now we want to find out the time for the simple harmonic motion. Let the time under the simple harmonic motion from B to A is a t1. So how to find out this t1? This t1 time can we find out by considering the associated circular motion. That is the easy way. Through associated circular motion for the simple harmonic motion, our aim is we want to find out the time for the simple harmonic motion. That means from B to A. A to A. A to A here. That means B to A. A simple harmonic motion. This time is equal the particles move in the circular path. This time. Time taken to travel on a red color circular arc. So from here, this angle is the alpha. So what is the cos alpha? From this distance A to M, this is the A by 2. Radius of this circle is a 5A by 2. That is the amplitude. Therefore, cos alpha is equal A by 2 divided by 5A by 2. 1/5. Therefore, alpha is equal cos inverse 1 over 5. And this circular motion also is omega, angular velocity. Therefore, what is the time t1? T1 is equal alpha over omega, this angle over omega. Circular motion time. That is equal to the simple harmonic motion time. This arc make an angle alpha, therefore the time is equal this alpha over this omega, angular velocity. This one 1 over omega into alpha. Alpha cos inverse 1/5. Therefore, T1 is equal square root of A over G to cos inverse 1/5. This is a simple harmonic motion time. Now we want to find out the gravitational motion time from A to O. Let the time is T2 from A to O. Here. But we already find out at point A the velocity of square root of 6 ag here. And point O, we already calculated the velocity square root of 7 ag. Therefore, more distance A, so we can find out the time T2. Using the equation of motion, V is equal U plus AT. Final velocity square root of 7 ag is equal initial velocity square root of 6 ag plus G cos 60. Gravitational acceleration vertically downward. Therefore, in the AO direction, G cos 60 plus the time T2. Therefore, G T2 by 2 cos 60 half is equal square root of AG in bracket square root of 7 minus square root of 6. Therefore, T2 is equal 2 into square root of AG over G within bracket square root of 7 minus square root of 6. When we simplify further, T2 is equal to 2 into square root of A over G into within bracket root 7 minus root 6. So the total time for the motion from B to O, the simple harmonic motion, time T1, from here gravitational motion time T2, total time. For this T1 here, square root of A over G into cos inverse 1/5 plus T2, this gravitational motional time, 2 into square root of AG over root 7 minus root 6, total time. So when we simplify this one, square root of A over G is the common factor out of the bracket. Within brackets, cos inverse 1/5 plus 2 into K. For this K is this quantity, root 7 minus root 6. Where K is equal root 7 minus root 6. The total time. This one. We already calculated. Total time. This is next part. The particle P reaches O and strikes the barrier. Impact with the barrier. The motion like this one. Come and impact and then rebound. Back, then rebound. Particle P strikes the barrier at O and rebounds. Strikes and rebound. This one. Separate diagram I mentioned. Right and D. Strike the barrier with the velocity. You already find out that V square root of 7 ag. So rebound velocity is equal Newton's restitution is equal E. We are given coefficients of restitution is E. Coefficients of restitution is E. Therefore, strike velocity V. Therefore, rebound velocity is equal EV. strike velocity V, rebound velocity EV is the coefficients of restitution between this barrier and these particles. Therefore, E into V, square root of 7 AG. Now, the particles rebounds and moving along the inclined plane under gravitational acceleration. We say let the particle comes to rest at a distance L from O. At a certain instant, the particles comes to rest. So we want to find out this distance L. That means resting distance. How to find out this L? Using V squared is equal to U squared plus 2AS. Final velocity 0. U squared. Initial velocity EV. E into square root of 7 AG, all things squared, minus gravitational acceleration. Now particles moving upwards. Now minus components of the gravitational acceleration G cos 60. Now here 2 into G cos 60 into this distance L. When we simplify this one, 7AG E squared minus GL. So L is equal 7A into E squared. If the resting distance, the particles come to rest less than the distance A, the string will never get taut. Therefore, it is not possible for the simple harmonic motion. If the string gets taut, then possible for the simple harmonic motion. Before getting taut, if the particles come to rest, therefore that is under gravitational motion. Therefore, not to be a simple harmonic motion, this L, the resting distance, definitely might be less than this distance A. So, not to be a simple harmonic motion, L lies between 0 and A. L lies between 0 and A. No simple harmonic motion. Therefore, 0 into L, we can substitute 7A E squared in A. Simplifying further these inequalities, divided by 7A, 0, here E squared, here 1 over 7. Simplify further, 0, this one is 1 over square root of 7. Therefore, for this condition, in this condition, not possible for the simple harmonic motion. That is the question. So that if E greater than 0, less than or equal 1 over square root of 7, then the subsequent motions of P will not be a simple harmonic motion. That is true.